All right, here's solutions for problem 1. You're given these 15 data observations, or I guess you're given a stem and leaf plot that has 15 observations in it. So the first thing is to be able to read this thing to understand that this 6, for example, means an observation of 16. This 9 means an observation of 29. This 5 is just 5. Okay, and then what we're supposed to do is sketch a histogram of this data using bins of length 4. So okay, the first thing you got to do is hit stat, and then go under enter or edit and enter your data. I already did that. If you need help with that, I got a video on entering data that you can find. But to save time, I already put it in there. I figure that's something you probably don't want to watch me do. And then what we want to do is make a stat plot. So if you hit second and then y equals, we'll get into our stat plot menu up here. And what will pop up is something like this. And if you hit enter to go into your first one, what you first want to do is turn this first stat plot on. If it wasn't already, you can hit enter. Second thing you do is you select what kind of stat plot you want. So there's the first one, there's the second one. We don't want those, we want a histogram, this third one. So turn it on, select the third type, and then tell it where your data is. I put my data in L1, but if you would put it somewhere else, you could just hit second and then 3, for example, to get to L3. But I put mine in L1, so I'll put L1 here. And now I'm done creating my histogram. I just have to figure out how I want to view it. And so what you want to do for that is hit your window key here and set up all your bounds. So I had already set these up, but the basic idea is your smallest observation is 0, and then your bin length is 4. That's this third thing here. And our biggest bin, let's see, it would go from 28 to 32 if you count up by 4s. So that's why I have this 32 here. Then my minimum, I like to put -1 in there to have a little border on the heights. And my maximum I put in 6 because that's a little bit more than my biggest bin. And leave everything else alone and hit graph. What will pop out will be something like that. So what we can do is create our histogram over here. And let's see, we got bins of length 4, so 0, 4, 8, 12, 16, 20, 24, 28, and 32. It's a little hard to read. Probably just making it worse. Anyways, we'll just copy this histogram here. It can be helpful to use this trace function. If you hit this trace key right here, and it will say, for your bin going from 0 to 4, you have 3 observations. So 1, 2, 3, 4, 5, 6. 3 observations would be right here. In our next bin from, get over there, 4 to 8, we have 2 observations. Something like that. Our next bin, from 8 to 12, we got 5 observations. So something like that. Our next bin, from 12 to 16, we have 2 observations. In our next bin after that, we also have 2 observations. And then we have none from 20 to 24, none from 24 to 28, but one guy here from 28 to 32. So just one way out here. You get a histogram that looks something like this, give or take. Good enough, so there's my histogram. Comment on the shape of this data. I would argue this is right skewed. Looks right skewed. It's not that far from normal. It almost has that bell shape. But to me, it looks like most of the data is over here on the left, but we kind of have this little tail cruising off down here to the right. But I guess it's a little bit subjective, so you could probably argue that differently. Looks right skewed because most data is on the left. But there's a tail to the right. All right, I guess that's the end of part 1. Good enough. So part 2, we don't want to use our stat functions, or at least not for a little while, just to check our answers. But what we do want to do is calculate mean, median, comma, mode, range, standard deviation, variance. Fine. Mean. For mean, you use the symbol x bar. And the formula is you want to sum up all your x's. So that says sigma xi. And you want to divide that by n, number of observations. So what we want to do is look at all our observations up here. 0 plus 0 plus 0 plus 5 plus 7 plus 9, 8 plus 9, 2 10s, an 11 and a 12, a 15, a 16, an 18, and a 29. We want to sum up all those numbers, and then we want to divide that number by n, which is 15, the number of observations we have. If you add all those up, I think you'll get 150. 150 divided by 15 is 10, which is our mean. Moving on, median. The median is going to be our n plus 1 over 2 observation. So n is 15, so it's whatever 15 plus 1 over 2 is, it's that observation. 15, which is the 8th. 15 plus 1 is 16, divided by 2 is 8. It's our 8th observation. 8th smallest, I guess. You can kind of count up. 1, 2, 3, 4, 5, 6, 7. Looks like our 8th observation is a 10. So our median is the exact same as our mean in this case. Mean, median, mode. Mode is the most frequent observation. And our most frequent observation, I think it was 0. 0 showed up 3 times. We got 2 10s. Nothing else repeated, it doesn't look like. So 0, which equals 0. Mean, median, mode, range, standard deviation, and variance. All right. Range is kind of easy. It's just your largest minus your smallest. So our largest observation was a 29, and our smallest was a 0. So our range is 29. Variance. Maybe I should change colors because variance is going to take some room. To figure out variance by hand, it's kind of a pain. So we're going to do it this one time, and then in the future we'll just use calculators. What you want to do to figure out your variance is you first want to list all of your observations. So we got 0, 0, 0, 5, 8, 9, 5, 7, 8, 9, shoot. Doesn't really matter that they're in order, but to try to not make this confusing, I'll put them in order. 10, 10, 11, 12, 15. I'm going to run out of room, maybe. 16, 18, 29. Squeeze that in. 16, 18, 29. First column, all your observations. Second column is x bar, whatever your mean is. Figured out our mean above was 10, so you just list 10s all the way down to the bottom, 10. Next column is the difference between each observation and your mean. So this column minus this column. 0 minus 10 is negative 10. 5 minus 10 is negative 5. 7 minus 10, negative 3. 8 minus 10, 9 minus 10, 10 minus 10. 11 minus 10 is 1. 12 minus 10 is 2. 15, 16, 18, and then finally 29 minus 10 is 19. Sorry, that got kind of small at the bottom. Your last column will be, want to get rid of all these negatives, and the way we'll do that is by squaring. So negative 10 squared is 100. 5 squared is 25. 3 squared is 9. 2 squared is 4. It's supposed to be a 4 there because 2 squared is 4. 5 squared is 25. 6 squared is 36. 8 squared is 64. 19 squared. Oh, my calculator froze. I'll figure that out. Hold on one sec. My calculator, so I want to figure out what 19 squared is. 19 squared is equal to 361. So that goes down here. And then I have to add up this whole column. Yeah, I'll do that on my own. Hold on. You add up all these numbers, this sum. How can I write this? Sum of all these numbers is equal to 831. Is that what I said? 30 is what this ends up being. So add up all those numbers, you get 830. And finally, we can figure out our variance. Oh, where should I write this? I guess right here. So your variance, sample variance, you use the symbol s squared. And the formula is it's the sum of, that's what the sigma is, that last column, xi minus x bar squared. This last column is the square of these guys. And then divide that by n minus 1, so 14 in this case. So we get 830 as this sum. And if we divide that by 14, 830 divided by 14, we get approximately, what, 59.29? Something like that. Which is a lot of work, but the good news is you can figure out your standard deviation pretty easily if you figured out your variance. So maybe I'll do that over here. Standard deviation. You use the symbol S, and all you gotta do is take the square root of the variance. So all we gotta do is figure out what's the square root of that number we just figured out. So I'm gonna say take the square root of that answer, and my calculator is going to tell me that's 7.70. That's my standard deviation, variance, range, mode, median, mean. I believe that's everything. Yep, think we're good. Oh, you can check your answers. Use your calculator's stat function only to check your answers. Sure, I could show you how to do that. We already have all the data in there from back when we made our histogram in L1. So I'm going to hit stat here, and then I'm going to go over to calc, and then choose one variable statistics, first thing there. And then I should tell it where my data is. My data is in L1. It defaults to L1, so you could have left that off, but I'll put it in just to illustrate. Hit enter, spit out all sorts of stuff. It'll tell us that our mean is in fact 10. Nice. Our median is in fact 10. Awesome. Mode, it won't tell you. Range, it won't tell you. Variance, it won't tell you, but standard deviation, it will tell you. Maybe I already went past it. There it is, standard deviation, 7.699. I think that's exactly what we came up with for standard deviation. We rounded off to 7.70. So it gives us our standard deviation. If you want to check the variance, you can just square this number, and you'll see that that gives you this number. And mode and range, no way to check with one variable statistics, but they're not all that hard, so we don't really need to check. So I guess that's it. That's finally the end of this perfect problem.